Hi students, let me go with the module 1 combination logic circuits. In digital system design, first we will understand about what is a digital. Meaning of a digital is logical ones and zeros. Where all we can see the digital system. I think you can see in the TV remote, TV, washing machine, even in your digital watch. Wherever you can see the operated with the logical ones and zeros, it is a digital system. See, as I said, it is a logical one or zeros. Here we can say 1, it is called as a true, 0, it is called as a false. With this, the voltage level of true and false, it is 5 volts for a logical one and 0 it is for grounded or 0 volts. So this is a simple logical system. Let me take one example, logical system example, then we can see that. So I have the staircase light control, have the 2 switches. This is, let's say, S1 and this is voltage level, and we have the another switch, S2, and that should be a circuit to control your bulb. This is the circuit we need to design in such a way that how I am requiring. Let's say I given the voltage level as this. With respect to this switches, I need to control my lamp. This is L. So any digital system design, what we need to look on. The first step we need to look on is we understand the problem definition. What is the problem? And definition of this problem we should understand. Second one is we understand the problem. Second, we need to determination of input and determination of input and output. So with this example, I have the 2 inputs, S1 and S2. Outputs are L, only one output. So the next concept is third one. We are supposed to write the, with respect to the problem definition, we write the truth table for this problem. So what is the truth table we are supposed to write? What is mean that truth table? See, in this truth table I have the input, let's say S1 and this is your S2 switches and we have the L. See here the combination is 2 combinations of the inputs. Combination in the sense it is a permutation, something like how you are operating the switches. It may be a both should be on, and it may be a any one switch can be on, or both switches will be off. So that is a combinationally we are supposed to give the input. So we have two inputs in the sense the combination definitely will get us 2 power n combination. So 2 power 2 obviously will get the 4 combinations. What are the 4 combinations? So let's say this is 0 0, one combination, 0 1, 1 0 and 1 1. See, this is what we called as a combination of inputs. With this combination, what you are expecting your output? That is what we need to suppose to write. As I said, it is on or off. On we can say logical 1, off you can say logical off, 0. When both the switches are 0 0, it means both the switches are off. Your lamp should be off, that is 0. So any one switch is on, it is just connected here and your lamp will be on. Here the same way S2 is on, again the L1 will be on. Both the switches are on, the circuit will break, so your lamp will be off. So this is the truth table to define how your output responds to the combination of input. So this is what I written the truth table. Next we have the fourth step is from this truth table we need to write the logical diagram. So what is logical diagram? It consists of logical expressions. As we know that here I need to consider with respect to the L is 1, logical 1, I considering as 1 1. With this 1 1, what I supposed to get the input variables. So this is what we call it as a variables here. So what L, when L is equal to 1, I supposed to get the expression as for this 1. So this is S2 bar S1 plus, and this is what S2 and S1 bar. Later we'll understanding with respect to switching equation the form of this equation, and all the literals, all the variables are considering as here is logical 1. Similarly, I can get the another expression with considering as zeros. So here is S1 plus S2, I considering as 0 here, plus into S1 bar plus S2 bar. So this is S1 because I am considering 0, it means that 1 in the sense complement of that 0. So that was S1 bar. S2 is 1, considering 0. So this is S2 bar. Here I am considering all the variables are logic 0. This is another kind of expression. But variables are considering as here is logical 1. Here the variables are considering as logical 0. This is how we can represent different form of expression. So here the variables are in the form of product. All this product we add it together. So we made it as sum. So this expression we call it as sum of product. This is sum of product terms. And here the expressions are sum containing all your variable. All the variables whichever you sum, that you made it as product. So in this, considering logic zeros, your expression it is in the form of was product of sum. So remember, so SOP, that is sum of product, the variables are considering as logical 1. Here product of sum, all the variable considering as logical 0. One more important concept here is, if you consider it as logical 1, all this variable we call it as min term. It means that in the SOP expression we considering as min terms. In the considering as logical 0, all the variables we considering as max term. So pass consists of max term, SOP consists of min terms. Min term represent logical 1, max term considering as logical 0. So this is the form of a logical expression. From this logical expression, we are supposed to write the logical diagram. Hopes from the logical diagram we'll get the two type of expression. Most probably always the output L is equal to L bar. Both the output are the same with the combination of this input. That means when it is same in the sense, when the min term, that is SOP, always complement of POS. SOP is always complement of POS. Whichever the expression you are taken as a min term or the max term, it is all consisting of your variable with this truth table are all equal when SOP is equal to complement of POS. Let me write the SOP expression with the diagram. So as we know directly, we can see that this is S2 bar S1, that is 0 1 into 1 0. It is a operation of XOR. So I can directly write the expression. It is with the variable of input is L, with the input is S1 and S2. So this is XOR. So that means that here you in the combination circuits, you can write the gate, XOR gate of your input. So then your lamp will be operated. So this is your combination circuit, what you designed here. This is what we call it as combination circuit. Later I'll come to that what is the features, what is actually the combinational circuit. We'll complete this part. So from this there is no simplification further. If this truth table aggregate is easy, if required we need to simplify the Boolean expression. Whatever we get in this Boolean expression, we're supposed to simplify. by using your Boolean laws or some of the method what we are going to learning further. Okay. After simplification, implementing your combination circuits. Similarly, this is the operation of XNOR operation. So also we can write it as S1, S2, XNOR. This is should be L bar. Whatever you are getting zeros, it is L bar. This also your XNOR operation. So this is how we need to design or implement any combination logic circuits. Now we'll come to the what is a combination logic circuit. What is this part? What is this combination circuits? See, once you given the input, automatically your output changes. Here is required any memory? No. No memory required to store your data. There is no memory here. So I can say directly the combination circuits is a circuit in which your output responds directly to the input changes. Here it is no storage element are involved. Like a memory, it is not involved. This is called a combination logic circuits. It means that in combination logic circuits, the output variables are dependent on the combination of input. The L is always depend upon your input, not any other memory. So in this combination circuits, I'll briefing the statement. See, this is my combination circuits. Combination circuits. I have an input, let's say x1, n number of input, xn. I'm getting an output y1, y2, yn. So whenever as I said that your output depends on directly the input, y always depend upon your x with the function of combinational circuit. So I can write the expression y is equal to f of x. Your x is a function, whatever the y is equal to the function of x. Right? So in this block diagram of your combination circuits, we have n inputs, n output. Let's say x is your input, y is your output. So the combination function f operate on the input of x to produce the output variable y. So this is how we can define the combinational logic circuit. So with this we have so many examples to work on the combination logic circuits, and later classes we'll see the different form of combination logic circuits. I'll briefing the content of here. The digital system, which works on logical 1 and 0. 1 it is true, 0 it is false. In the voltage level, 1 is 5 volts, 0 it is a ground. So how we can define my combinational circuit or design steps we required to design my combinational logic circuit. Its example is staircase light control. As you people work on that, you can see in the videos. So how it will be operated? I written my circuit here. We have the two switches. There is a combination circuit. To implement the output is L here. First we understand the problem definition. Next, second step is determine how many inputs are required, how many outputs are required. We have required 2 inputs and 1 output. With this, we need to write the truth table. As I said that 2 input variables, in the sense we are supposed to write 2 input combinations. That is, always the combination is 2 power n. That is 2 power 2, that is 4 combinations is required. So 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. I written this. So with this input, what you are supposed to get an output. When both the switches are off, your lamp is off. When both the switches are on, your lamp is off. When any one of the switches is on, your lamp will be on. This is what you written the truth table. The next step is supposed to write from the truth table to implement your Boolean expression, to simplify the Boolean expression and implement the logical diagram. First let me write the Boolean expression with respect to the logical one. So I written in the logical one in this form. I am considering the logical 0, I written in this form. So all logical ones, I can say it is all min term. The expression is in the form of SOP, that is sum of product form. Considering as a logical zeros, the expression in the form of POS, product of sum. So that is what we represented. So as we know that always SOP is equal to complement of POS. So implement this logical expression into logical diagram. The first what we getting as a SOP expression, it is in the form of XOR gate, POS expression XNOR gate. So this is supposed to be implemented in this combination logic circuit. So here once you operate the input, obviously we'll get the output. That means that output variable is directly depend on the input variable. This is what the combination logic circuit, the meaning of combination. Here it is no required of memory element. So similarly, I'll take one simple block diagram. As I said, I'm the combinational circuits. I'm briefing that. We have an n input and n output. Your function f is the combination circuit. It operates the input of x, will get the output y, so that y is equal to f of x. So hopes you understand. Thank you very much.